So this is problem 11 on practice midterm 1, and it reads, in the figure shown, the coefficient of kinetic friction between the block and the incline is 0.4. What is the magnitude of the acceleration of the suspended block as it falls? So here I have the diagram that we're given on the midterm. And so the first step is to draw free body diagrams for both of the blocks. So for the block hanging down, the 2m mass, it has the force acting downwards, which is the mass times acceleration, and it also has the force of gravity acting on it, which is 2 times the mass times the force of gravity, and then it also has the tension acting upwards. And then for this block right here, it has the tension going upwards and the opposing tension going downward, which is mg sine theta, and then it has the normal force acting up. And to oppose that, it has mg cosine theta because the block is neither going into the plane or into space. And then it also just has the force of gravity acting downward here. So the equation that we can write for this is the force going downwards, the 2ma, is equal to the force due to gravity minus the tension pulling upwards. And then we can rearrange the equation in terms of t to make it t is equal to 2m g times g minus a. So the first thing that we are going to do is do the force, which is ma, is equal to the tension, which is opposed by the force of friction, which is F, minus the opposing force downwards, which is the mg sine theta. And then we can further that because we know that the force of friction, if you can see it here, is equal to mu times the normal force, and we know that the normal force is opposed by mg cosine theta, which means that they're equal. So then we can rewrite this to be ma is equal to t minus mu mg cosine theta, mg cosine theta minus mg sine theta, and then we can plug in the value that we have for t over here. So we have ma is equal to 2mg minus a minus mu mg cosine theta from this value, and then mg sine minus mg sine theta. So now we have a lot of like terms, so we can cancel out all the m's, which is good because we weren't given any masses in the first place. And then we can write it out to be a is equal to 2g minus 2a minus mu g cosine theta minus g sine theta. So we have these two values, the two a values, so we can move this over here to have 3a, and then we can now, since this is gone, can factor out the g. So we can do 3a is equal to g times 2 minus mu cosine of theta minus just sine of theta, because we moved the g out. So that is all equal to a, if we divide by 3, a is equal to 9.8 times 2 minus 0.4, which is the mu, times the cosine of 40, which is what we're given in the photo, minus sine of 40, all over 3, because we divided by this 3 here to just have a by itself. And that would give you a is equal to 3.43 meters per second squared. And that's it.